are the data normally distributed? And are the data points interrelated or are they independent? First question, how many groups? So when you use a menu-driven program, very often the menus would ask you how many groups are there. Are you comparing 2 groups or are you comparing many groups? And this is SPSS. In SPSS, it does not ask you how many groups. Here, it would just ask you, I have the menu, you pick compare means. Okay? And then, in that menu for comparing means, you have the t-test and the one-way ANOVA. You have to know how many groups you're comparing in order to pick the right test. Okay? T-test can only compare 2 groups. If you have more than 2 groups, you need to use one-way ANOVA. What kind of data do you have? Do you have data that is parametric? Okay. Do you have data that is on a continuous scale? And is that continuous scale data normally distributed? And if the data is not normally distributed, t-test and one-way ANOVA are not the right tests, because the t-test assumes a normal distribution. If your data fails the normality test, or after you run the normality test, there's more than 5% chance that the distribution is not normal, and you go ahead and run the t-test, your t-test result is not valid. So if in the absence of normal distribution, then you would need to use a non-parametric test. Okay, then that, in SPSS, it would fall to a different menu. Anybody can do a t-test. The question is, are you picking t-test as the right test? Is it the right test to pick? Even Excel has the capability of doing the t-test. But in Excel, it's a little difficult because here, this is the code for the t-test. Okay, L6. All right, so that in this first field here, you specify the cells that contain the data for your sample 1, so L6 to L15, okay? Here, in this, after the comma, you specify the cells that contain the data from sample 2. And then, after another comma, you specify whether your test is a one-sided test or a two-sided test. Okay, you have a 2 for the two-sided test. And then you specify the type of t-test, whether it's a paired t-test or is it an independent t-test. And the independent t-test assuming equal variance for both groups, or an independent t-test assuming unequal variance between the 2 groups. So all these numbers and fields, you have to know. Otherwise, you type in the wrong number, you end up with different things that has no meaning. So here, to do the t-test in sigma plot is very easy. Okay. Here you pick, compare two groups, and then click, 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 and then out comes your data. And it tells you that normality is passed. Okay. Many programs will automatically perform the normality test for you. And when the normality test fails, it will default and recommends a different test for you. So that is why this program is good for beginners, good for novice people, because they would do these things for you to help you, to guide you to the right test. But many other programs do not do that, and you have to know ahead of time to ask the 4 questions that I mentioned earlier in order to decide which test to use and do the right thing. Now, in SPSS here, compare means, and another compare means, you pick t-test, whether it's paired or independent samples. And this is the output from SPSS, and it will tell you what the significance of the t-test is. So you do the statistical test, and then now you have found a statistically significant difference, and then now you want to present your data, now you're writing your paper. And when you write your paper, how do you present your data graphically? How do you present, like for example, here I have the data from 2 groups of cells, the CD14 negative cells, CD14 positive cells, okay, 2 groups, 2 samples. So how do I compare, how do I demonstrate or present this data graphically? Very often people would just plot the mean using a bar chart. I personally prefer to present the data using a box plot. Okay. Have you all heard of a box plot? Okay. Now, why do I prefer a box plot? Because the box plot not only shows you the mean, it shows you the 25th, 75th percentiles, the 90th percentiles, and the outliers. And if you prefer, you would also show the mean as well as the mode. Median. Very often, I guess Prism is another very popular graphical software that people use. These graphical softwares, or the graph output from SPSS, when by default using the parameters, there's usually something like this, and they look ugly. Okay, how do you make a presentable graph good enough for publication? Okay. What are the qualities of a good graph for presenting in meetings or putting it into a manuscript for publication? So here, comparing with this, okay, size of fonts. Many of the reviewers are old people, and old people are presbyopic and difficult to see small letters. And especially, many journals are very tight on space. Very often your graph will need to be shrunk a lot. The bottom line is you need to pull up that graph, and from 10 feet away, you need to be able to see clearly from 10 feet away. If you cannot see that, the font is not large enough, the lines are not thick enough. So you need to have thick lines, heavy fonts, big fonts, so that it can be seen far away. Color contrast. Good color contrast would help, especially for old people like us. And many of the reviewers are old people. And use of color. sometimes you can do not use color indiscriminately. Indiscriminate use of color will only distract. You use color to emphasize your point. Here, for example, I use red color to emphasize the mean. Here, the mean almost coincides with the median. And is pretty symmetrically distributed on both sides. So if you look at this sample, one look, you can tell that this would definitely pass the test for normality. This sample is normally distributed. But what about this one? There is a wide gap between the mean and the median. And it is skewed on one side. It is questionable whether this distribution or the distribution of this sample is normal. In this situation, when you have one sample without a normal distribution, is the t-test the appropriate test to compare the difference between these two groups? No. So that is why I prefer the box plot. Because with the box plot, you can tell the basic characteristics of the sample very quickly. Just one look. In just one look, I can tell you that if the author tells me that the t-test is give you a p-value of less than 0.05, and I'm the reviewer, I say, bullshit, go back and do the calculation again. So, graphical presentation. And again, this is a bar chart. Comparing with the default output, enlarging the fonts, making the lines heavy, would make this visible from far away, and you can shrink this to a very small size and fit into the journal easily. And